In question 3.1, we are demonstrating a SQL injection attack on a vulnerable web application which is at www.seedserver.com. SQL injection is one of the most dangerous and common web application vulnerabilities. It occurs when a user input is directly embedded into a SQL query without proper sanitization. This allows an attacker to inject a malicious SQL code that changes the intended logic of the query. Uh, in the demo I'll present to you, I'll have two goals. First, we'll bypass the login page to log in as Ted without knowing his password. Second, we will use a SQL injection attack in the edit profile page to modify users' data without their knowledge or their password. First, let me verify the Docker containers are running. We have the web server at 10.9.5. Yeah, we have the web server at 10.9.0.5 and MySQL database at 10.9.0.6. Uh, Let me show you before performing the attack the vulnerabilities that exist in the PHP source code. So W 10.9.0.5 var www SQL injection unsafe underscore home dot php. Yeah, just look at this. Yeah, just look at this lines of code. uh, the input name, the input username, the input pwd, and the hash pwd. There are several vulnerabilities here. First of all, the username and password are directly taken from the get request using $get and placed straight into the SQL query string without using a string concatenation. There is absolutely no input validation or sanitization that is happening here. Second, the application uses uh, a SHA1 string for the password, which is considered weak and outdated as per the modern standards. Just one sec. Yeah. Third, the query uses a string interpolation, meaning whatever the user types in the username field gets embedded directly into the SQL query. As you can see here, this means an attacker can type an SQL code in the username field and it will be executed as the part of the query. A secure application would prepare statements or prepare some queries which will separate the SQL code from the user data, which makes the injection impossible. But this application does neither of those things, making completely vulnerable to SQL injection. Now I'll open the vulnerable web application in the browser and show you. HTTP www.seedserver.com. Yeah, this is the login page of the vulnerable application. It just looks like a normal login page, but underneath it is a completely vulnerable to the SQL injection. first let me explain the attacks before performing it. The normal SQL query, legitimate one. Yeah, see, the normal SQL query is here. This would only result both if the username and password will both match, but as you know, this is vulnerable to SQL injection attack. This won't do so because it asks for the hash password and this one doesn't. It just uses SHA1 as an input password. Uh, Now, if I just one sec. Yeah, yeah. If I type something like select name as Ted and star, the single quote after Ted closes the string that started where the name is equal to and the single quotation. The hash symbol in a MySQL comment is a character. Everything after the hash symbol is ignored by the database. So the entire password check and the password, like if you type anything, is commented out and never executed. The query now only checks if the username Ted is correct and the even if the password is completely ignored. The database finds the Ted's record and returns the login page without any password. Now I'll perform the attack. In the username field, I'll type the injection payload, that is TED apostrophe and hashtag. As I said, anything after the hashtag is completely ignored, and the signal code, the TED star, closes the string. And as you know, anything after the hashtag is completely ignored. For, let's say, for the sake purpose, we will type the password as in anything, and this will get validated. Not now. Yeah. So as we can see, we are now logged in as Ted, and see he can his complete profile including employer ID, salary, birth, SSN, etc. All without his password. The SQL injection attack was successful and has bypassed the authentication completely. Now I'll demonstrate the second part, like making an unauthorized modification to another user's profile. First, let me show you the vulnerable query. Sorry, www s SQL injection unsafe edit backend dot php. Yeah, as you can see here, the update credentials set nickname input is equal to dollar input email. Again, the same vulnerabilities exist here. User input from the form field is placed directly into the SQL query without any sanitation. The dollar input nickname variable comes directly from what the user types in the nickname field. The where $id at the end is supposed to ensure only the current logged in user record gets updated. But as the nickname field is vulnerable, I can inject that as an SQL code that, first, that is closes a nickname value early using a single quote, additional set clauses to modify other fields, and completely replaces the where clause to target an identified user, a different user. This means I can update any user's profile while logged in as Ted without knowing the user's password. I'll now click the edit profile button while logged in as Ted to access this vulnerable form. This is the Ted's edit profile image. Normally, this form should only be updated by Ted's own profile, but because of the SQL injection vulnerability, we can use it to modify Bobby's profile, which is the another person. So I'll type this field, yeah, where name is equal to Bobby. Let me explain exactly what happens here. So the single quote after the first comma closes the nickname value. The single quote after the first comma closes the nickname value. The email is equal to uh, a Herschel at rate RMIT at rate edu.au sets Bobby's email to my RMIT student email, uh, where the name Bobby completely replaces where the original clause, like uh, here, Bobby's name would be taken instead of Ted. As a result, Bobby's email will get updated instead of Ted's without Bobby's password. Now I'll type the injection payload into the nickname field. Just quickly let me change my student ID because I guess it's wrong. Student.rmit.edu where name is equal to Bobby. Uh, yeah, let's just leave other spaces as blank. Now I'll just click on save. Let's log out from here and log in as Bobby. As we all know, Bobby's password is Bobby Bobby and seed Bobby. Okay, sorry, Bobby Bobby. Not now. As you can see, Bobby's profile has now my student email ID. We logged in as Ted without even knowing like what Bobby's password is. This demonstrates like how dangerous an SQL injection attack and its vulnerabilities are. An attacker can not only bypass authentication but also modify other users data information without any authorization. So yeah, this is all for question number 3.1. Thank you so much.